world of artificial intelligence, machine learning, and data science. Today, we gather here to explore the cutting-edge technologies and that are reshaping our future. Namaste and good morning. My name is Sandhya Bogati, and I have the privilege of being your host for this incredible journey of knowledge and discovery. Before we start, I would like to express our gratitude to all the individuals and organizations that have made this event possible. We're gathered here today at Vincent Vasana Hotel on the date of June 8th with a lineup of speakers and interactive sessions planned throughout the day. Before we start, let me introduce the organizer of this symposium, which is Lumbini Technical University, a newly established university in Nepal, located in Nepalganj, Baake. As an emerging institution in the educational landscape, Lumbini Technical University has shown its commitment to fostering research, innovation, and industry partnerships. Today's symposium is the collaboration between Lumbini Technical University and the industry leaders, Mountech Solutions, Naami Research Center, and Machine Learning and Data Science Community Nepal, MLDSN. Mountech Solution focuses on areas like artificial intelligence, machine learning, data engineering and data science, natural language processing, computer vision, software development, and IT consulting. Similarly, Naami Research Center aims at building a solid research and higher education foundation in AI, informatics, and applied maths in Nepal. Also, we have our technical partner, National Research and Education Network, NREN. With this short information about the organizers and partners of today's symposium, let me introduce today's guest. First of all, we have our chief guest of today's event, who is Vice Chancellor of Lumbini Technical University, Professor Dr. Binod Prasad Dhakal. Let's give him a round of applause. Next, we have Mr. Reg Bhandari, Registrar of Lumbini Technical University. Similarly, we have Dr. Kirti Kusum Joshi, Dean of Lumbini Technical University. Also, we have Ms. Asmita Mananda Shrestha, project lead of eSatya, which is a blockchain initiative of Rumsan Group. She's not present here. I hope she will come later. Also, we have Mr. Ashok Kumar Panta, Chief Technological Officer and co-founder of Treeleaf AI Technologies. Similarly, we have our international guest, who is Dr. Ashutosh Modi, Assistant Professor in Computer Science and Engineering, CSE Department at IIT Kanpur, who will be joining us via online. Also, we have Dr. Binod Bhattrai, Adjunct Research Scientist at Naami, Nepal. Likewise, we have Dr. Bishesh Khanal, Research Scientist and Director at Naami, Nepal. Similarly, we have Dr. Janak Parajuli, co-founder of Machine Learning and Data Science Community Nepal, MLDSN, who will also be joining us via online. Next, we have Mr. Tej Sai, who is Associate Professor of Computer Department of Computer Science and Information Technology at TU University, who will also be joining us via online. Last but not least, we have Mr. Surya Basnet, co-founder of Mountech Solutions and Machine Learning and Data Science Community Nepal. Let's give a big round of applause for all the guests present here. Okay. By bringing together professionals from various fields, this program aims at highlighting the importance of bridging the gap between academia and industry and providing a unique platform for exchanging knowledge and ideas. Throughout this day, we will dig into the exciting world of AI, machine learning, and data science. We will explore how those technologies are transforming industries, revolutionizing decision-making process, and paving the way of innovative advancements. So now let's start the program officially. To begin, we have a welcome speech by Dr. Kriti Kusum Joshi, Dean of Lumbini Technological University. We are incredibly grateful to have him here today to share his invaluable insight with us. Let's welcome him on the stage.
Thank you, Sandazi. Respected Vice Chancellor of Lumbini Technological University, Registrar of Lumbini Technological University, distinguished speakers will be sharing their knowledge and expertise with us today, and all the participants who have joined us today in person as well as via online platforms. It is my immense pleasure to welcome you all, and thank you for being here, joining us on a very short notice. Before going into the topic of today's symposium, let me first take this opportunity to introduce Lumbini Technological University. It is a new university. Many of you might not have heard much about this university. We are a very new university. In fact, we are not even a year older. So established by Lumbini province in alignment with the constitutional power bestowed by the Nepal's constitution. Lumbini Technological University aspires to become a center of academic excellence in the field of technology. And we have 5 focus areas to begin with: engineering, IT, agriculture, forestry, and tourism, with technology as a binding factor. Very soon we'll be launching academic courses on computer science and information technology, and this symposium is a part of our strategy to develop academic programs and curriculums based on market demand as well as the status of emerging technologies. Now, coming to the topic of today's symposium, artificial intelligence, machine learning, and data science. These topics are very hot topics now. Not new, not very new, but the relevance has increased. It's passing day. Particularly, we all know that recently, ChatGPT has taken the internet world by storm. Earlier, we used to many of us AI used to be a very technical stuff that only computer scientists and IT engineers understand. But when we started to use internet, when we started to use Google, and when we started to use smartphones in particular, we started to realize that companies, they could track our online activities, and they would know our interest, our likes and dislikes, the food we eat, the food we want to eat, the places we visit, the places we want to visit, the purchases we make online, the things that we want to buy, and they would provide us tailored content. But now, at that time, like AI used to work in silent. It used to be hidden in our devices. But now we are inviting AI by using ChatGPT, by installing AI-powered browsers and apps. So we are slowly inviting AI into our daily lives. And technologies are becoming very powerful. And as the saying goes, with power comes great responsibility. With great power comes great responsibility. Technologies can be used and technologies can also be misused. There are associated opportunities as well as risks. So one of the 2 objectives of this symposium is to enrich and inform our academic programs and curricula by understanding how we can, how we should, or how we could accommodate or address emerging technologies in our programs, by also understanding the associated opportunities and risks. And the second objective is to engage a larger audience because in this discourse, because we believe that universities should also play a role of a center that not only produces knowledge, but also disseminates knowledge to the general public. With this short note, I would again like to welcome you all and thank you all for joining us today. And I hope that we'll have a very productive day. Thank you.
Thank you, sir, for your warm welcome speech. Now, moving on, we have an opening keynote address by Dr. Binod Prasad Dhakal, Vice Chancellor of Lumbini Technological University. Let's welcome him on the stage with round of applause.
Register to participate or physically participate here, to participate or about our university, Lumbini Technological University, something I didn't explain here. After me, our registrar also introduce about our university as well. And now, because of my subject, my field is a mathematics, not a computer science, but I know mathematics is very useful in a computer science, even though not in the field of computer science. During the preparation of these slides, I've seen so many mathematical terms, mathematical topics which are teaching in my classes. So I associate or I explain how the mathematics is related or have a relation with the computer science. Yes. In my presentation, I have include these things, some examples where the computer, in computer mathematics is used, what the importance of mathematics in computer science, mathematics and artificial intelligence, mathematics and machine learning, mathematics and data science, and conclusion. One quotation that from University of Oxford, I like it because of what the relation between mathematics and computer. Mathematics is a fundamental intellectual tool in a computing, but computing is also increasingly uses a key component in a mathematical problem solving. Because of the, for computer science, basically mathematics is essential, but in a mathematics, several mathematics problem is solved by the computer. I think GeoGebra, MATLAB, Mathematica, all these are the software which is developed from the computer science, which give several many solutions, which is very difficult manually, but using the computer or IT, the problem of mathematics are very easily solved and feasible. It shows that what the relation between mathematics and computer science. Some examples which is related with mathematics and computer. This is a Google map. All of we, everywhere, we use that Google map. Actually, this Google map GPS system is run by mathematics. The mathematics terms here, the graph theory. This is a branch of discrete mathematics. Computer graphics. In computer graphics, there are two technology, which are digital photography, film, video games, digital arts, cell phone, and computer displays. Many more applications are there. These all are strain on the mathematics because of linear algebra, which is associated with computer graphics, and that computer graphics is run by using the linear algebra. And now, ChatGPT. In this nowadays, that ChatGPT is taking everywhere. This is an example of a genius of AI, and in this genius of AI, mathematics, linear algebra, statistics, calculus, discrete mathematics is used for these AI. Zero, one, binary system. A binary number system, this is a two-digit, there is a two-digit, 0 and 1. Somewhere I read it because of the computer circuit, there are two things there. One is on and another is off. Because of there is a two thing, so two digit is essential. These are 1, 0 and another is 0. So for binary number system is used for that programming, hardware programming, that binary system are very useful there. Hi Shri, will it raining today? The chance of a rain is 30%. Take your umbrella with you. This is also the use of computer science. This is a classic example of a machine learning. And for these statistics, mathematics statistics is used because of this is a speed, recognized software. I have shown these examples, which are example of a that computer science, and where the mathematics are used. Mathematics is a foundation for it. For any program, every program, a computer scientist need to a basic mathematical knowledge. However, the type of a label depends on the area of quantum. What the how depth or what the area you want to go in a computer science. In this way, the depth of the mathematics knowledge is assurance. Why the mathematics is so important in a computer science? Mathematics is a foundation of a computer science. Every courses of a computer science, there are very basic mathematics is in it. But every discipline of a computer science, the logic notations, set theory, that combinatorics, graph theory, probability, number theory, algebra, all mathematical that topics, units, absolutely is essential there. algorithm that is a very important in that computer, and this is impossible with mathematics because of mathematics teach the use of algorithm. To solve the problem, any type of a problem, the analytical skill is essential. That analytical skill is developed from the mathematics. If you know mathematics, then you can solve any type of a problem by using the analytical skill. So to develop the analytical skill, mathematics is essential. Mathematics introduced the abstract language. The mathematics have its own abstract language. I have shown here some symbol operator which are used in mathematics. This symbol also in a computer used. So without reading or without studying the mathematics, you cannot understand or know this type of abstract knowledge. Mathematics concepts are required in many more other discipline as well, like operating system, database, networking, AI, embedded system, data analytics, and many more that field mathematics is essential. Mathematics and AI. AI is all about the integration of a mathematical concept and programming to give the output that makes the human being. That AI slowly became a part of our life. We could realize AI has become associative. I've already mentioned that pulse rate. Google now, that Amazon, Alexa, these all are an example of AI. For AI, what the mathematics topics or mathematics is, what the mathematics field is used. The linear algebra, probability theory, discrete mathematics, statistics, and calculus are essential for that AI. Machine learning is a branch of AI, and computer science is focused on the use of data and algorithm to imitate the way that human learns, gradually improving the accuracy. A list of daily life application of a machine learning is face recognition of iPhone, auto find tag suggestion by Facebook, Google Map, knowing the traffic pattern, email spam filtering. These are the use of machine learning. Four mathematics pillars that are required for machine learning are calculus, linear algebra, probability, and statistics. And mathematics and data science. Data science is an interdisciplinary field that uses the scientific methods, process, algorithm, and system to extract the knowledge and insight from many structured and unstructured data. At present, data science as a career has a extremely future ahead. It is predicted that this industry is likely to grow by 36% to this decade. For domains and mathematics that are crucial in data science is linear algebra and metrics, probability and statistics, calculus, geometry, and graph knowledge. The data science, here I have the suite, Venn diagram, 3 suites. The data science is an intersection of all these 3 sets: domain of expertise, computer science, mathematical, and scientific methods. These are the 3 sets, and their intersection is a data science. And the machine learning is the intersection of a computer science and mathematical and scientific methods. Here are some example of in the daily life regarding the data science. Airline companies predicting the easy about the flight delay, notifying the passengers about it. Likewise, logistic companies like DHL, FedEx. This is also used in the data science. And the data science, there is one pyramid. From below, the data is collected and then move and store, explore and transform, aggregate and label, and learn and optimize. This is also a Venn diagram. The relation between AI, ML, and DS. Artificial intelligence, subset is machine learning, and data science is a intersection with artificial intelligence and machine learning as well. So in a computer science, in my conclusion, in computer science, whatever the mathematics is essential. The computer science is a vast field, and there are a number of professions and that can be pursued in this field. However, any field be chosen, basic knowledge and understanding of a mathematics is crucial. The domain of mathematics that act as a pillar of computer science are discrete mathematics, linear algebra, calculus, and statistics. Having a basic concept regarding these domains will help in making a learning process easy and understand. This is my references.
Thank you, sir, for giving us brief information about importance of mathematics in computer science. Our next speaker is Dr. Binod Bhatrai, Assistant Professor in Natural and Computing School of University of Aberdeen, UK, and an adjunct research scientist at Naami, Nepal, who is here to give us insights about machine learning on self-supervised learning and active learning. Let's welcome him with a round of applause.
Good morning, everyone, and thank you very much for having me here. And thank you very much from team Lumbini Technological University, and welcome everyone in my talk. So uh, I am an assistant professor at University of Aberdeen, and I lead a lab, multimodal learning lab. Also, I am a co-founder and adjunct research scientist at Naami, Nepal. Also, I hold an honorary lecturer position at University of London. So today I'm going to talk about self-supervised learning and active learning. So how many of you are have background in computer science students? All right, so I mean, my talk can be a bit technical, so but I'll try not to be. And okay, so this lab is at University of Aberdeen and Naami, Nepal, and these are my lab members. And we do research in computer vision, machine learning, even medical image analysis, multimodal data, active learning. And we are pretty new and young lab, but still our achievement in the past years have been tremendous. So we have publications in leading journals and conferences, and also we have won the global challenges. So before diving into my talk, so I'd like to start with some tasks to you actually to solve a puzzle. So these are the puzzles, right? So A and B. So from this two puzzles, so can anyone tell what does that A represents and what does that B represents? So obviously A is a tiger, right? So basically, so then the B, if I give you B, then yeah, it's a painting, but reconstructing the original painting can be a difficult thing. Do you agree on that? Right? So we can manage to reconstruct, if you just play like a couple of times, so you can basically move those blocks and you can reconstruct tiger easily, but it will be difficult for us to reconstruct the painting, right? So, but if we give the same challenge to a painter, a professional painter, then the painter might find the right one much easier than us. So it can be difficult, but then relatively much easier than us, right? Do you agree on that? So how this has been possible? So it's because we know what the tiger is, isn't it? So it means, so knowing something would help us to fix these puzzles or solve this puzzle. So if I rephrase it again, so if we are trained to solve these kind of puzzles, then ultimately we will understand what that image represents, or actually what that image is. Okay, do you agree on that? So that's what exactly is self-supervised learning. So because basically supervised learning means we show you some example, then we teach you like, okay, to the machine, even the machine goes into the similar philosophy, right? So like, when we go to school, so we start, the teacher starts showing us some symbols, and then basically we say, oh, this is A, B, C, D, and then, keep on. So this is like some kind of supervised learning is there that needs some kind of annotations, experts to, basically guide you. But then self-supervised learning algorithm in machine learning means something we don't need label. Meaning, for example, for this tiger, I mean, we don't know what is there, right? So if we just create so many puzzles, creating that puzzle is not just to create that kind of puzzle. I mean, we don't need to know what exactly that image represents. But so if we are trained to solve the puzzles, then that would uncover the underlining, the content of the image. So that's what we want to do, right, in AI. So basically image recognitions or, the text summarization, and so on. So I'm taking a bit of time to give you some insight, and then I'll basically, go run a bit faster. And also, I would like to give you another analogy. For example, I think you young guys, you don't have that problem, but when you reach like 40s or like then cross this, then we suffer usually from blood pressure and high blood pressure thing. So then what does this doctor say? Like, so every morning you have to walk, right? So then that would basically manage your blood pressure. So it means, so we are not to lower the blood pressure. There is not something like we pull it down, right? So we do walk, and that results into lowering the pressure. Similarly here, so if we basically, generate this kind of puzzles, that's one instance. Okay, there can be different ways. Okay, and then try to solve those things, using the computer algorithms. Then computer starts actually discovering the content of the email or text or basically other stuff like so that's what exactly is self-supervised learning. Okay, so I'll try to introduce what is self-supervised learning and then active learning. These are the two components to learning paradigm in machine learning. Okay, so far so good. Any questions? All right then, so these are the outcomes. So okay, then so why do you want to learn the structure in data, right? So if we just, am I audible by the way? It's audible, right? So okay, so if you can see this graph here, so the x-axis represents amount of data and the y-axis represents performance. Okay, so do you know like how many examples or how big the data was used to train, let's say ChatGPT or this thing? So the billions of examples are trained, used to train this, but not in a supervised manner. Okay, so but for example, there are other models on image recognitions. If you have heard about this thing or not, like segment anything or this thing. So then these are basically trained in billions of training examples. Okay, so what I mean to say here is that even from that graph, you can see that the amount of data that is required to train a model in a supervised manner is growing massively. And then, so, it would be very difficult to collect, data. So basically, if we want to employ this AI in medical image analysis, like you will never manage to get billions of data points because of various reasons, right? Privacy, or also we don't want like billions of people to be ill to collect the data, which is, it's not possible, isn't it? So then how can we make AI? So that's an active research. So without basically, using those labels in an unsupervised or self-supervised manner that can exploit on-level data. Okay, so that's what this self-supervised learning and both even active learning comes into picture. All right. So also self-supervision, again, I want to give you another analogy that just having some kind of knowledge is not enough for doing some downstream task, right? For example, you watch football. So for football, you need to run and you need to be very strong. So, but then do you mean like every runner can, or a strong person can be a footballer? No, right? But being strong and then like, someone who can run, which is, high stamina is essential, isn't it? But that is not the only thing. All right. Similarly, having some prior knowledge is good. But if you really need to like, do some specific tasks correctly, then you need some kind of supervision. Like even that someone who is, fit and runner, you need some coaching to, how to attack or, basically, basically there are so many tricks in football, right? So similarly in the machine learning also, like taking millions or billions of on-level data and training the model in an unsupervised or self-supervised manner is not just enough. Okay, so we need at least some fine tuning, some supervision to fine tune the model or specialize the model. All right. So we know what ChatGPT is also, right? So what does this ChatGPT does is it's trained in a self-supervised manner, a language model called GPT. So have you heard about language model? What's language model? Okay. So then that language model definitely captures the structure, underlying structure, semantic and syntactic structure of languages. But then, to make that conversation like seamless is not possible because that model is not trained in the conversations like millions of conversations. It's not. It's trained in the text. Okay. So what I mean to say here is that, gaining prior knowledge is very important, right? It's good. Like, for example, if you are very good in GK, so you can crack Lok Seva. But then if you really need to work, then you need some training, right? But that helps, right? So basically, so that's intuition here. So idea here is that you can use self-supervised learning, gain some prior knowledge, and then we need some small training example to specialize in the downstream tasks or the tasks of our interest. Okay, so let's look into the, so basically I showed you a puzzle, some kind of grids, but then, this, all the materials, surrounding, they exhibit some structure. Okay. So basically that structure, if we can exploit, then we can discover, uncover the knowledge, right? Even in the language, so language are not the sentence, they have the grammar, right? Definitely, they have some morphology. So they exhibit some structure. So then the idea here is that, so can we exploit that kind of structure to learn or teach the, AI to understand the languages? All right. So even this ChatGPT, the backbone behind the ChatGPT is model trained in this form. So if you look here in the text, so Alaska is about something, so there is a subject, verb, and then object, they follow some structures, right? So then how these models are trained is you can mask some of the text, and then you can use that context to predict the text, the marks text. So then you cannot just, predict the marks text until and unless you don't know it. You don't have knowledge about it, right? Okay. So that's how, basically the algorithms are trained, learn the parameters, and that's basically later on used to train the tools like ChatGPT. Okay. So then, okay, so masking is one thing, and then how do we translate them into mathematics? So like Professor Vice Chancellor, sure, he mentioned about mathematics, he mentioned about the relationship between mathematics and AI. So then, okay, so then we mark some words. Then how to translate them in a form of equation or mathematics so that you can optimize, learn the parameters to satisfy the constraint that you impose, right? So for example, there are sentences, we can mask it, and then basically we can, learn the parameters to predict, given this context, the missing words. And we would like to maximize the probability, probability, right? So probability, also Vice Chancellor, you mentioned about the importance or significance of probability. So what you want to do is that, okay, given the context, you want to maximally, maximize that the prediction made by the computer is correct. So that's what for that, you have some kind of objective function that's is like minimizing log likelihood, negative log likelihood, okay, or maximizing the likelihood, right? So I cannot go into the details here, but then, somehow you can use it in the future. So again, so coming back, so gaining this, again, coming to this fitness is not only, so we need to specialize it. So something like that, even in the machine learning. So if we use self-supervised learning from massively unlabeled data, that may not be accurate. Then we need to basically, fine tune it to for the downstream tasks. So we mentioned ChatGPT, it's a hot topic. So then how does it work? you know. So that chat GPT is based on a language model called GPT. So they have the different version. So that was trained on billions of sentences, you know. And so ideally, you know, in the supervised thing, if we really wanted to make chat GPT as good as that we have now, let's say, in a the supervised manner. So we need billions of conversations, which is, you know, real conversations, which is not possible, right? So the thing is that, okay, there is one the conversation between two, and we take several examples and then train it. So which is not possible. Then what exactly it is done here is basically they use this language model trained in a self-supervised manner or unsupervised manner. And then they took some examples, like for example, the examples from us. So every time we make conversation, they are also used, you know, for training, retraining the model, because we provide the feedback, right? So basically when we make a conversation and we say like, okay, this is not correct, right? Then if computer makes mistake, then there is a system to penalize it. For example, if you did your teacher penalize you in your class, like if you make some mistakes, so then if you are penalized, then you don't do it again, right? So the same thing here. I mean, basically, there is a mechanism of penalizing it. So then it tries to make correct, you know, prediction in the next time onwards. All right. So so I mentioned about supervised self-supervised learning. Then before jumping into that, I want to briefly give you what is supervised learning algorithm is in terms of it in a formal way. Okay. So far it was abstract only, isn't it? So in the supervised learning, so you'll have level data. So then you take input. So X is input and Y is output. So that can be anything, like in terms of if you want to do image recognition, then that can be different categories of images, right? So depending upon your downstream task. So then there will be some kind of feature extractor, because the image pixels are not just good enough, because there are so many redundancies and also like it's so high dimensional, right? So to recognize, for example, if your friends, how does your friends recognize you? Just focusing on some peculiar characteristics, right? So there are something, you know, in your face that your friends have never noticed. Still, your friend can recognize you. So it means we don't need all the features to, you know, to identify you. So then, so its feature extractor is something that extract important features out of it that is essential to, you know, recognize. And yeah, so then the model is, you know, task set means like the task is specific, your downstream is task specific features, and you make prediction, and then you learn the parameter to make the correct prediction during training. So if model makes mistake, then it will be penalized. Okay. So that's the supervised learning algorithm. So it means for supervised learning algorithm, you need some kind of annotations. Okay, ground truth annotations. All right. But then compared to supervised learning algorithm, what is self-supervised learning algorithm? Means it also needs like annotations, but the annotations are self-generated. Okay. So I showed you some puzzle, right? So that was kind of annotations used, because for that you don't need any, you know, the categorization of the images or the knowledge about the images. You can simply do that, right? So the idea here is, you know, you will have input image, no label, and then basically this pretext talks. So basically that pretext talks is the idea of generating annotations in a self-supervised manner. All right. And so this a model learns the parameters to, you know, for example, to solve that challenges. So I'll show you some example more like what else can be done. Okay. So then the image are feed into like feature extractors. This feature extractor, you know, basically first, you know, trains on this self-supervised manner using this pretext talks, the annotations based on the annotation generated in a self-supervised manner. And then later on so basically I also mentioned you like, do you remember like, you know, just self-supervised learning is not enough. Like having just prior knowledge or strength is not enough. You need some guidance, you know. So then once you learn the parameters in a self-supervised manner, then what you do is you initialize. So use this feature extractor parameters, freeze it, and then you will have task head. Task head means like your downstream tasks, you know. So you can use the same model for different tasks. Let's say image recognition or detection or some other regression task, you know, depending upon your requirements. So have you ever used like ImageNet model, treated model and applied on different tasks? So something like that, okay? So then you take some few level example. You take some few level examples to fine tune your model, and that basically, you know, can make, can be suitable for your task. All right. Great. So then how do we generate this pretext tasks, you know, that without any supervision? Okay, that can be very essential, I mean, useful in your daily life as well. So let me directly go into this thing, like introducing some pretext tasks. So I showed you puzzle, but other than that, you know, so rotation angle. Okay, so the rotation angle can be another, you know, pretext tasks on the cells, the annotation that you can generate in a self-supervised manner. So for example, if I show you this phone, so then if I rotate you like, let's say this angle, so you can easily tell like how many angle, I mean, approximately. Okay, so what is its orientation? What angle it is oriented? All right. So if you had no clue like what this device is, then you cannot basically tell like, you know, in what angle it is oriented. Meaning, so, you know, something accepting a challenge to identify the orientation angle, meaning that is indirectly tells you that, you know, you should understand what that exactly the object is. You see, right? So in the indirect manner, you basically uncover that knowledge. All right. So similarly, these rotations are used, and then basically they are used as some kind of label. So you can rotate in different angle, and then basically learn a model, you know, to make the predict the angles, you know, correct manner or correctly, right? Other than that, so this puzzle, solving the puzzle is also another annotations that you can generate in a self-supervised manner. And I'm a bit quickly going here. So for example, colorization. So what you can do is that you can take a color image and you can easily extract its grayscale image, right? And then you can basically train your model to predict this, the original color given the grayscale. So then to predict that color intensity correctly, you should understand what is there in the image, okay? Right? Otherwise, you cannot do it, isn't it? So something similar. Yeah, I mean, that's what we can do for even computer. Okay. And yeah, so again, we can use that kind of labels to train a model. And even for example, in painting, so what you can do is that you can take images, you can crop it out, and then basically you can train your computer or the algorithm to, you know, predict the missing parts. So you can only complete the missing part only when you know what exactly that image represents. Otherwise, you cannot do it, isn't it? So we do apply similar techniques in computer as well in terms of algorithms. Okay. So, this is some kind of active research topic. So basically, there are different ways people are exploring, researchers are exploring. So other than this, like, you know, predicting the rotation angle or missing parts or this thing. So other than that, we can also come up with different ideas. Let's say this is called contrastive learning representation. So what does this contrastive learning does is, so you can take an image then you can rotate it. So then you can make a pair of it. So original image and then let's say rotated image. And you can randomly take any other image and you can make two pairs. One pair positive pairs means original image and its rotated version. And then another image and the original image makes negative pair. And then you can basically train your algorithm to, learn the representations, again, extract the features in such a way that, the original and its augmented version or the rotated versions come closer and the another image goes farther. Okay, so to do that, basically you should also be able to understand what that image is. Otherwise you cannot do it, right? The same way we can train the computer, design such algorithm and then computer, we can learn the parameters and that actually, such kind of learning algorithms actually help computer to recognize the images. Yeah, so this is the idea. So the idea here is, the idea here is there is anchor, there is negative and positive, and after learning what we want to do is that anchor and positive, they come closer and anchor and negative, they go farther. Okay. So this is one algorithm. So not going into the details here. Yeah, so basically what I wanted to show this number is that you don't really need to care about the number, but the idea here is that, this kind of algorithms are, pretty effective, sometimes even better than supervised learning algorithms. And other than this, like I showed you example on images only, but that can be used for cross model, meaning like image and text. So if you use Google image, what you would do, you type the text and you retrieve the images, right? So something similar here. So basically the image and text pairs are taken and then, they are learned in such a manner that, the text and their corresponding caption, let's say, have similar representation. So they are mapped together. Okay. And also it has not only been limited for, okay, so it's not displayed there. Okay, so this has been also been used in medical image, in medical domains too. Okay, so there is X-ray and then X-ray report. So then this kind of technology can be used for, you have X-ray and then you want to generate the report. So basically, this kind of technology is used automatically generating the report. You see. All right, so there are further readings. So if you are interested to know, you can find other literatures. So I will go to active learning thing. So, but before that, I would like to check the time. So this is another concept in machine learning. This is called active learning. So the idea here behind active learning is also like, so have you heard about active learning before? Anyone? Can you please tell what is active learning? Just in a minute. You don't have to tell in the AI term. Just, basically this has been used in teaching profession as well, like, student teachers, actively teaching. Anyone want to volunteer? Okay, so active learning is some kind of interactive thing. So basically, the active participation between the teacher and the student so that they interact and they identify where the gap is with the student and then fill the gap. Okay. The same thing applies here. Similar thing applies here in active learning in this paradigm as well. So before, like I told you, like example in the SIP, I gave you some example of supervised learning algorithm, right? So in the supervised learning algorithm, you use annotated data, you keep on feeding. Like there is an image, okay, this represents this, okay, for example, and then we train the parameters. So that is something like unidirectionally we are feeding. So, but we don't know what model is learning out of it. Okay, and we don't know where this model fails. Okay, so the active learning is an iterative process where basically the model gives some idea that, okay, in which cases is the learning model. Model means the AI model, right? Is actually not confident or feel missing the gap. So then we identify such content and we basically feed again such examples to train the model. All right. So it's an iterative process. So what it does here is that you can see there are three components. This is learner, sampler, and oracle. So learner means machine learning model, the supervised learning algorithm that we use. Okay. The sampler means another, again, like kind of agent, or it's again like approximated by some mathematical functions or a model. It can be another model as well. But the idea here is that it gives you an idea of what kind of examples that you need to annotate in order to make the model more confident or more accurate. Okay, because we don't need all the data to train, because there can be a lot of redundant information, right? So we want to add new or extra information. And the oracle means it queries the label. So for example, you have a bunch of unlabeled data. So then you want to train a model. So then what you will do? So the thing is that first thing you need to do is that you need to annotate the data and then basically train your algorithm, right? But the question here is that what examples, which images, let's say, if we take example, which images should I annotate? Should I annotate all or only few of them? So then the answer is that, we might just need a few of them to annotate. We don't need any, like everything to annotate. For example, I mean, to be genius or wise person, you don't need to go through all the Wikipedia pages, right? So you can learn infer from even a small number of, the books, I mean, or, the text. All right, so if I have to differentiate what is active learning versus this passive learning, passive means like, we are not interacting now. It's kind of passive here again. So I'm just, delivering. I don't know what is the response there. So, but if you can interact, then basically I can identify where you are. Okay. So there is a wall, there is data. So basically there is data is feeded and then the model is trained. But in active learning, what it does is that there is data coming in. So there is an active learner. So basically that active learner interacts with the world, then tells like, okay, I am less confident in this part. Okay, I need more examples from here. So then basically the data are collected and then basically train it again. So then that's the process of active learning. Okay. So then why do we need active learning? You see, so expensive annotation protocol, right? So medical image, for example, I'm telling you many times, because if we want to develop algorithm for medical domain, then even if you get images, so annotating data, I mean, we cannot annotate. I cannot annotate. You cannot annotate. We only need experts. And how many experts will we have? And, and we don't, I mean, just one or two examples are not enough. So we need thousands of examples. So it is very costly and time consuming too. So there is a data set called MS Coco, Microsoft Coco data set. So to annotate one data set, so it's about object detection, so detecting the bounding box. So, but to annotate an image, it takes almost 346 seconds. So this is too precise number, and so that's quite a lot, isn't it? So, and data complexity, like noise present in the data makes it ambiguous, and privacy and security. So basically, it's not like you can transport your data from, in some cases, basically you cannot really transport your data. You have to do annotation in-house. Okay, so in this case, it's impossible if you just have to start annotating every examples. So then you can see here the two curves. So one blue curve is the learning curve from the active learning framework, and the below one is from passive. And x-axis shows the percentage of data that you use to train the model, means like selected you to train the model, and y-axis is the performance. So you can see that active learning is consistently outperforming passive learner. But then can anyone tell why they converge at the same point after, like, to the end?
No. It's because we all end up like even after active learning, we end up selecting all the examples. So then there is no point, right? So for example, for example, if you had 100 examples, so then active learning algorithm selects, let's say, first 20 examples. Then in that case, okay, active learning can identify the most useful example. But if you end up like annotating 100 examples, then there should not be a gap, right? Because we are using the same amount of data. No, I mean, we don't want to go to that concluding point. Yeah, but we don't want to go to that concluding point because one thing you need to be very clear here is that, the data set that you have is not the real representation of data, right? You can have 100 example, then you cannot say that, okay, this is the whole data, right? No, because you managed to get only 100 examples, right? So then the idea here is that out of 100, let's say you have 100 data and then you have 50 rupees to annotate the data, okay? You are given just 50 rupees. Then the idea here is that how do you want to maximize the performance? And each of the annotation cost is 1 rupee. Then you have only like chance, the maximum you can annotate 50 examples out of 100. Okay, so how do you do it? So the active learning can help you in that case. Okay, so we don't want to go to that point because there is no point offline there because the data that you have, I mean, if you have a small scale, then you can annotate all. But if you have million, so then after like 300 or 500, let's say in some cases, only 40% of the data out of millions are just enough to reproduce the result of a model that is trained on whole data set. Okay. Does that answer your question, by the way? Do you have any questions then, please? Yeah. No. For example, if you end up like, even after active learning, if you end up selecting all the examples, then why would you get different result? No, right? Yeah, that's the point. But that's not the aim of active learning. So as I said, let's say that you have million images, let's say, and you are given, let's say, a $200,000 to annotate. And each of the images costs, let's say, $1. So how would you want to maximize the outcome of it? Okay, so in that case, active learning would be very useful. And also, as I said, like 100 examples are not a true representation of your data. So that's the only data that you have, but you don't have whole data set. We don't know what is the true representation of data. Okay, so we can just approximate. We cannot like fit the, we cannot manage to get all the data. All right. Okay, so then this is a theory of it. So basically, taking the time into the consideration as well. So I'd like to go a bit quicker. So the thing is that the idea here is it's an iterative process. So you start with on-level data, you have on-level data. So you start with some small amount of data annotation that you might have to do in the beginning randomly, right? Because you don't have any model to guide you like the sampler. So these are annotations called seed annotations. Then using those small amount of data, then you train a model. And then from that model, you also approximate this sampling function. And sampler would suggest you like what should be the new examples that you need to annotate in the next iteration. And then you keep on iterating it. Okay. So there are different strategies to do active learning. So what is uncertainty sampling? So uncertainty sampling means a model, like, we are iteratively training our model, right? So then from this model, we can estimate the uncertainty of the unlabeled example. For example, if we pass one unlabeled example and then, so, have you heard about this entropy and some kind of randomness? Like, for example, if you show some feed one example to a model, and then if model started like, predicting that, okay, it is likely to be cat, it is equally likely to be dog, it is equally likely to be tiger or something like that, then that's too uncertain, right? So you're so confused, isn't it? So someone can say, oh, I'm so confused, I don't know what it is. So that's uncertainty, So everything is equally probable, but actually it doesn't happen, right? So that's some kind of, quantifying such kind of uncertainty. And based on that, basically you can sample and then use them to try to train the model. And diversity means like we want to cover the data in a diverse manner. Okay, so that can also sometimes help. And query by committee means like there are certain models, they are committee members, and they vote based on the uncertainty or other criteria, and whichever gets like the majority voting and for selection, and then basically that's kind of more examples are selected. Okay, so the uncertainty sampling means, as I mentioned, like so if you are training a classifier, the dash line, so the hyperplane means like that separates the classes, and the examples which lies near to the borderline, they are likely to be uncertain, right? So we want to basically clear those things. So that's why we select such examples. And there are different way like entropy. So entropy quantifies the uncertainty, right? So it is P log P, right? So the probability is from 0 to 1, isn't it? So do you know the logarithmic curve? How does it look like? Log 1 is equal to 0, right? Well, but less than 0, it goes more negative value, isn't it? So then, meaning like if your model is making predictions, uncertain predictions equally, like let's say point to point, because the summation of probability is 1, right? So if you have like 10 classes, then if it is too confused with every classes, then what it can do? It can make 0 0.1, 0 0.1, 0 0.1, 0 0.1 for all the 10 possible classes. Then you compute the logarithmic log of P means 0 0.1, log of 0 0.1 is too high, isn't it? Then if you sum up it, so the value will be too high and it is negative, right? So that's high entropy. So that's how you can quantify it. Okay. So yeah, so there is like margin. So you can also see the margins between these first most confident and second most confident. That's another criteria, and that confidence is like also the confidence of the highest predicted class. Like these are the criteria, different criteria that can be used to sample the examples. So, but the problem with this uncertainty-based sampling is that it can only focus on difficult example nearby the hyperplane, and sometimes it can get biased towards each examples. So that could provide valuable information sometime, and the limited exploration it cannot explore. Basically, it can confine on only with the difficult examples. And another is diversity sampling, like meaning like you have dispersed data points, and you want to make sure that the selected example belongs to every clusters of the community, basically. So right. So even in like our country, everything like we want some kind of diversity and inclusion and representation. Actually, this is important. Yeah. That brings complementary information and complementary strength. All right. So then, yeah. So basically, it's called one of the approach is called core set approach. So I'm not going into the details in the mathematics. So the idea here is that so you'll have some clusters, and then from each of the clusters, you'll have already some initially selected examples. So then in the next iterations, when you select, so basically you make sure that you select the most different example from this different example from the clusters. Okay, that's called core set approach. And yeah, so this is first for that you need to create this core set and you compute the distance. And yeah, so the idea here is that from the clusters, you have each of the clusters, and from the clusters you want again the diversity there. Okay. And this is something like we visualized, like what kind of examples were selected here. So maybe it's not really great. So all the points represents the data set overall, but this black dotted cross points are only selected by our algorithm. So it means like we are not selecting every example. See. So I try to introduce you two concepts here, self-supervised learning and active learning. So, but then the motivation here is to cut down the need of, annotated examples. Approaches are different, but there is chances, there are definite potential to bring them together, because when active learning has some kind of chicken and egg problem, So the problem here is that because we have sampler, which again based on the model trained on annotated examples, but then our aim is not to have many, select many annotated examples. So then when your model is suboptimal, then the example suggested by active learning that the model may not actually be the difficult example sometimes, right? So then it's kind of chicken and egg problem. So that, so there is some kind of research is going on, and even my lab is investigating this thing. So what we are trying to do is that maybe we can use self-supervised learning algorithm to kick off the active learning algorithm, so that when these algorithms make suggestions, may help us to select the real difficult and diverse examples. Okay, so yeah, so here are some results from the research. Yeah, this has been observed to be effective, so it's not that clear. Yeah, so that's pretty much from my side, and thank you for your attention. If you have any questions, please. Any questions from the audience? Yes, please.
Really the scope of basic learning in context of Nepal, especially who are doing undergraduate in Nepal, what is the scope of this basic learning and how they can achieve their goal, their career perspectives?
Okay, thank you very much for your question. So, this is really important questions. Maybe I'm not that great for this to answer, but still I can definitely, I'll try to answer it. Definitely, I think the AI has a lot of potential for the countries like us. For example, you see, let's say in the healthcare example, right? So we lack experts, and sometimes the screening process can be very lengthy. So if you can, develop such kind of tools that can basically, speed up the screening process, then the experts can help, take care of many patients, right? So that's one thing. And also, like, if we can develop some algorithm and low cost devices, for example, Vishesh is there, so he's working on he's developing a research, basically, detecting the cervical cancer using the smartphone images. Okay, so actually there are already technology exist, but then those technology are super expensive for the country like us, and it's not affordable. So if we can develop in assistance with AI and just taking these images from a smartphone and can help detect, actually it's quite accurate, and it's in the process of development. So then that can basically save the lives of many women in our country. So, or for example, arsenic, yeah. So for example, skin disease, right? So if you can, or glaucoma, or we cannot totally rely on this AI for like prognosis or diagnosis, but at least it can help accelerate the thing, and that can actually make possibility to reach out to the large number of people, which is the bottleneck in our healthcare system, for example, right? So I think this is the way we can do in other sector as well. If we can automate the customer onboarding process, or like even verification of documents, and even so even in the government office, that can protect. I think it's not only speed of the process, I think also even can lower the corruption, because if the middleman always they they don't do provide the service, without uh, without money. Yes, yes, exactly. That's the thing. All right, and so yeah, I mean, definitely even for like detecting, in the agriculture as well, maybe developing assistance technology to detect the, you know, the quality of the soil or plant diseases that can be detected. So that can also help. For example, last year I was in Ethiopia. This one of the event by Royal Academy of Engineering, UK. So basically, so what you observe there is that one of the major stable source of stable, I mean in Ethiopia is the wheat, and then there is wheat roasting is a very common, right? And what the farmers do is they just these pesticides just they spray everywhere, and that would definitely make thing. I mean, not really. And that's not good, right? If you basically, use them in a large quantity. So then AI can help. How it can help is that, identify the roasted plants and maybe, precision spraying of these pesticides can, prevent from the other consequences and also like prevent the crops from rusting, right? And even in our country, let's say, landslide, deforestations, everything, these things can be used. And yeah, and even in the traffic management, we need them everywhere, I guess. So there are a few to mention. And what is the perspective for the students, right? So the scope of the student is that definitely, as I said, like there are many fields or domains where AI is going to be, it's going to be effective. So then we need more and more people to work on it and skilled person, right? And definitely, I see a lot of opportunity for you, not only from the job perspective. So I think there is a lot of things or opportunities to bring by AI, right? And so, yeah, I mean, if you guys are really interested, and I think it depends. I mean, interest, but I see a lot of potential. And moreover, like the countries like us, because this is the field with, we can generate knowledge of our own. I mean, we feel like, okay, not only AI, the tools, right? So we also want to generate knowledge and contribute in this innovation, So then I think this is the domain, in my perspective, where even with small amount of investment, can make bigger, impact outcome, because we don't really need like heavy equipments to do research and study in this field. So if you are interested in like, okay, I want to be generate the knowledge and disseminate the knowledge, I think this is also an area where you can actually equal into that. Yeah, so I hope it answers your questions. Thank you. Thank you very much for your attention, and thank you, Lumbini Technological University, for having me. And it was wonderful seeing you all here. Thank you.
Thank you, sir, for your engaging and informative presentation on self-supervised learning and active learning. We have our next guest coming in, Professor Dr. Subarna Sake of IOE. Let's welcome him with a round of applause. Now, I would like to welcome Dr. Bishesh Khanal, a research scientist and director at Naami organization, a distinguished visionary in the field of AI and machine learning, to talk about the current state of AI in healthcare and its potential for the future. Please give a round of applause for you.
Hello. Hello, good morning, everyone. Can everyone hear me back there? Yeah, okay, thank you. Fantastic. Thank you very much, LTU, for giving this opportunity. So I'll be talking mostly about the healthcare AI and other researches that we do at Naami. First, a quick introduction about what Naami is. It's an organization, a group of researchers, Nepali researchers established with a vision of establishing a world-class center right here in Nepal and work in scientific research there to improve the lives of people in general. We have three major divisions. One is scientific research. We have different independent research groups that work on diverse sets of problems in applied math, informatics, computer science, and AI. We have education outreach division where we try to strengthen the capacity of higher education and research here in Nepal, and then also strong ties and building up industry and innovation capacity. Quickly with the research groups, we have at Naami our independent autonomous research groups, which does both theoretical and applied research in diverse field and have diverse application domains such as healthcare, agriculture, finance, or many different. And we've been working here for the last 3 years, almost 4 years now, and publishing research articles in some of the world's top research journals, conferences, and research different funding agencies, and we've been training some research training staffs. And we have different research groups such as transforming global health with AI, TOGAI, or multimodal learning lab, computational endoscopy. So these are different research groups led by different faculties. So you just heard the talk from Vinod. It's the multimodal learning lab. And I have another research group, transforming global health with AI, which I'll briefly talk about, but there are also some faculties as well who work on different groups. And we have some faculties which are supervising students or have their students here working on, once again, diverse fields. This diverse team, just an example, this is not everyone within Naami, but just 3 groups and examples of the students here. We also supervise master's thesis students, different master's thesis students at different times. So let's go to the research. So that's very brief introduction of what we do with our proof terms. Now we will focus more on a research kind of research, and I'll start with some of the research applications or some of the research work we're doing in TOGAI, where we do in different data like imaging data, language data, or even genomics data. And within imaging, there are different types of images. You can think of smartphones, ultrasound, x-rays. There are other images as well, but just show some example research work on this domain. And transforming global health with AI. So there was a question on the last talk, right, about what we can do here in Nepal. So a lot of these research actually builds or aims to solve important problems in countries like Nepal. So for Nepal, but not just Nepal, low middle income countries like Nepal, and especially in global health, there are 4 themes that we can think of, or 5, but let's focus on these 4 first. So the one is empowering the general public. Because healthcare means it's also about prevention. Many of you have heard about prevention is better than cure, right? So, and with the devices like smartphones or wearables, Fitbits or watches, right? All these, we have lots of data that we generate even when we are interacting with the environment and daily lives. So this can be an important source of data for doing lots of things at early detection and prevention. Then we have other outlines, but let's start with one example, what we are doing for preventing certain diseases, improving health right from the prevention using a smartphone device. And for many of you are, I think, aware of pesticide problems, right? So we have farmers who are either unaware or intentionally for commercial purposes put a lot of pesticides in fruits and vegetables. And these things come to us in our kitchen, and when we eat, it has the adverse health implications. But ideally, the government would be regulating this, but usually needs expensive device, spectrometers, and expensive machines to estimate the concentration of pesticides. And which means, again, there is not enough regulatory testings happening. And the idea we have with a collaborating institution, KAIAS, Kathmandu Institute of Applied Science, is what if we can just go to the pharmacy, day-to-day pharmacy, get a small kit, and then at your home, you can estimate the pesticide in your vegetables or fruits. If we can do that, that will empower the public to be able to estimate these pesticide concentrations, and it will put pressure on the government as well as the vendors, business people to not use too much of pesticides. So what we have is with the Kaya's team who built this paper analytic device. So what that means is you must have heard about litmus paper, right? So litmus paper for estimating the acidic content. In a similar way, we have pesticide and a certain solution which changes its color depending on the kind of compounds the vegetables are specifically sensitive to the pesticide compounds. It works with two families in this particular case, but so these changes, find minor changes in colors, we train the machine learning algorithm to automatically estimate the pesticide. So this is what we have done, and we have published the proof of concept already, and now we are going to test this, validate it at mass scale with partnership with like Nepal Agriculture Research, our government bosses as well, and testing in Kalimati, like centers like Kalimati, where what we have is you have a filter paper with the reference and the sample, and just with these colors you can actually estimate the concentration. This is one example where it's not direct clinical application, but it's directly related to healthcare and prevention. The other, Vinod, just a while ago briefly mentioned about the cervical cancer screening. So this comes under the theme of broadening the scope of health services in primary and community. So if in countries like Nepal, you have many primary health centers, community health centers. These are health posts in most of the areas, especially in rural areas and even small towns. So even if you think of wards, like Wada Health, Wada Swasthya Karyalayah, these kind of things, you cannot expect high experts like radiologists, consultants, senior doctors to be present there. It's very hard. But then how can we improve or increase the health services, kind of health service we can deliver at those points with the same existing manpower that we have? So this is what I call as broadening the scope of health services with AI powered systems, assisting the health professionals already existing in these areas with AI to make them able to do something more than they are already doing, right? And making them more capable to do advanced kind of testings. So cervical cancer is one of the major types of cancer for women in Nepal, and it's one of the largest killers, although this is a preventable disease. I don't know how many of you know, but if you can detect the precancerous stage at the right stage, you can actually prevent that from going into cancer within 5 minutes. So you can cure it, not just cure. So cure is after the disease happening. Here it's you know the early stage, even before the cancer, precancerous stage, and you can prevent it from happening. So this is so powerful, but still there are so many people dying of this. Although there is a very easy test, like what we call as VIA, visual inspection with acetic acid. So doctor is able, will see the cervix and visually, and we put some acetic acid and try to see the changes. And if there are specific kind of changes, you can treat it within 5 minutes. So despite this, why do you think there are so many people dying? When there is a very low cost 5-minute treatment that can prevent someone from having this cancer, why do you think so many women are still dying of this cancer? Anyone? Any reasons why we should have so many people with cervical cancer when there is such an easy test and treatment available? No one? Okay, unawareness, that's a good point, because you need to detect this pre-cancerous state and there are no external symptoms. So that means nobody would go to the doctor to check, right? So that means that's a huge, pretty classic case of having screening. What we call as screening is screening in healthcare. What that means is you want to, even without symptoms, on a certain regular basis, could be once a year, once a 6 months, depending on the type of disease. You want doctors or health professionals to test for a certain kind of disease here. So that's one problem. But even if they are aware, let's say, so if we have like millions of women across Nepal, where would they go to do screening? Especially in the villages, let's say, a larger amount of towns. Where should they be going? to do screening. Yeah, true. Yeah, so that's another problem. So lack of awareness is one, and the next one is that they are not comfortable, especially this is of cervical, so private areas, and they are uncomfortable. So now let's imagine they are aware and they are not ashamed. They want to go to the doctors. Then even then there is still a problem. Can you see that? What would be the next stage? Like, okay, now everyone wants to, let's say, test every 6 months. Where should they be going? Like all over Nepal. So where would that be? Let's say we are in one village in Xiangzhang. Exactly. So another problem is there are so many places like a village in Xiangzhang where ideally if they have to go regularly, like every 6 months or every year, the best place for them to go is their health post, nearest health post, right? And this is, I mean, as it's a low cost, you just need acetic acid and this treatment device, and you can do that immediately. So where is the problem? I mean, even in the health post, they could easily go and test, right? Or no? Can you see? Is there any other problem? Because the doctor will see and just detect it with a naked eye. So in those health posts, is it, I mean, it's fine, or is there still a problem? Exactly. So that's the biggest problem. Even with awareness, even with women willing to go, we need expert doctors, and there are very, very few of them who can actually do this, especially in those areas. And if we want to screen large fraction of people, that's the biggest problem. So what we are doing with the partnership with Arjuna at ISS is we are building an AI system where simple smartphone, we can assist the non-experts like nurses. Usually nurse and community health workers are available in those places. Even they can ideally do this screening and treat the patients. So for that, we're building this system, which is a work in progress. We have already have collected data from 1,500 women, and we will be going to remote areas also soon and build this system. So that's one example where you can actually have an impact. So just to give you an idea of why it's difficult. So this is the cervix, and usually this cervix, the place where it, if you can see, so this reddish part is actually it's usually inside the cervix. So this is opening of the cervix, and inside it should remain inside, and the rest is the outside part. So these two are like two different zones. Outside it's a different environment, inside it's a protected environment. But what happens is as slowly this inner part starts to come out, and when it comes out, now this has a different type of tissue, the other one has different type of tissue now. But as soon as this inside tissue comes out, it starts transforming into the tissue type of outside, because it has to adapt to this outside environment, which is more acidic and all this. And this is called as transformation zone. And this is where cancerous cells can start coming out. And this is the place where doctors start during this transformation. So there are certain kind of changes where these cancers can happen. And this can be seen by putting acetic acid and looking at this specific type of changes. And this is, I mean, for us, it's a bit tricky, difficult, because there are lots of points to take care of when it is precancerous stage or not. And it can, I mean, real cervix can come in all these different kind of shapes and variations. So and even the aceto white that we said, there is reflection, there is specular reflection of the light, and sometimes even it's not exactly white, is aceto white. And the structures, there are different structures, time of appearance, disappearance, density, mass. It's all these details are important, which we are not expert of, and these experts need to take care of when they are deciding whether it's not a cancer, whether it's precancerous or suspicious cancers. And this is what we have developed. We have a system in place which can take these pictures during this screening in very remote areas. We have a system in place that then once we have the data, we need to answer, especially if we are building AI system, we need to train the model with known pair of input and output images, which you might have known. But this, we need to annotate these images. So all these images that come in, first the doctors or the experts should say whether there is cancerous, whether this is cancer, not cancer, or suspicious ones. And we also have a system in place to do the quality monitoring and detect all these different types of structures within the cervix with an online web-based system. So all these images are real images in remote camps. And this comes to a central database in a server where we do all this. Experts do quality control, annotations, different kinds of annotations. And then we, based on that, we're building the AI system. So they do full classification kind of annotations and also different structures within the cervix. Right. And then, yeah, these are some snapshots of the systems. When different doctors can do different annotations, so we will also look into variabilities, because not, I mean, that's the other issue with this this kind of test is it's highly subjective. So 3 different nurses or gynecologists might give 2 different results for the same image, for the same patient. So we are also exploring, studying where does this subjectivity comes from? How can we make it more consistent, more objective? For these, we need to understand how they analyze these images. So we have a system in place where we have multiple annotators with their own account login system. They annotate and then we look into this. So that's something where if this technology comes in and it can improve the outcomes, it will actually save people's lives, a lot of people's lives if this is scaled. So that's the kind of impact we're looking at with machine learning system. The other example I would like to give is what we're doing here is AI assisted smartphone microscopy. So diarrhea, you might have heard there are still people dying in countries like ours from diarrhea, or even if they are not dying, is other issues like malnutrition, weight loss, and morbidity, what we call as morbidity. And 2 of the major diarrhea causing parasites, diarrhea and cryptosporidium. So what we are building with, again, with partnership with Kaias, is we have a smartphone microscope that just with simple smartphone and a small lens, we convert it into a microscope. So in a very remote setting, you can take it and prepare like slides and do the microscopy. But the challenge is again similar. Even if you have a small low cost device, unless you have experts who can analyze the images from those devices, it's very hard to use it in remote settings and low cost settings. And here we're building the AI system, deep learning models to automatically detect these parasites, which in real kind of images, it's can be fairly challenging because of other what we call as debris, so other similar structures around. And so this on the top row, what you are saying here is the bright field microscope. So that's the traditional microscope, the existing kind of microscope usually used in the labs. The below is the one we have from our smartphone, which is, and we have already published paper validating that this is good enough for doing the detection and using deep learning models also. And now we are doing the validation by collecting hundreds of thousands of data images in 3 different provinces in Nepal, in Janakpur, in Dharan, and in Assam, far western region. And we're doing this with stool samples, water samples, and vegetable samples, because you can use this test to detect this contamination in water, vegetables also, which can be useful for prevention measures, and in stool tests for diagnosing also. Right. I'll give another example, still with broadening the scope of health service delivery. So fetal ultrasound. Ultrasound is a very important imaging modality or imaging device for especially pregnant women. So for the pregnant women to look into fetal health, maternal health, and to manage the pregnancy, it's important to have ultrasound scanning and analyzing the fetal health, right? But the same problem in many places in Nepal, in health posts, you don't have expert radiologists. Usually radiologists in Nepal, there's this ultrasound. And what we are doing is we're doing a series of tools. There's so many different models and different tasks we do within this team, but I'm just showing one example here, is to enable non-experts, even the nurses there, to be able to do this ultrasound with assistance from AI and be able to manage the pregnancy. This can again save a mother's life, actually, if we are able to do that way. There's still many people, many women dying. Maternal and fetal mortality is still in Nepal is higher than compared to many places around the world. And this is just one example where what we're trying to do is in the bottom row, you in each individual one, this is one image, one snapshot of the fetal head. But the problem with ultrasound is you can see only a very small part of the whole head with one image. And usually for doctors, they should be able to go to specific area within the head to measure specific structures and to see whether it's abnormal, normal, or not. So to be able to go to a very fine specific target, one needs to understand the whole path, right? It's like you if you want to go to a certain destination, if you don't know the road, it's hard. It's the same thing. So the doctor need to be, and for the nurses or the non-experts, it's extremely difficult. This is something that radiologists usually train for years to do that. But what we are doing is we're actually building a tool where anyone can just go around the head. So in this case, not the fetal head, but in the belly, mother's belly, go around in a defined protocol, in a very easy protocol, same for everyone. So they don't have to look into images even. And we, with the AI, we combine all those images and reconstruct the whole head or a whole fetal in the future, and then detect all those important structures. Provide. So that's the bigger idea. And what you see on top is this is the reconstruction from many different images. On the right, what you see here is actually. So this was the work we did when I was in London actually. So on the bottom row here, it's the best view that a radiologist is able to get for a certain subject. And on top is what we reconstructed from all different views together. So especially in difficult cases where there is the fetus is covered with placenta or fetus is in not a suitable position, it can be difficult for a radiologist to get the right views. In this case, the goal was to find the nice face surface. And here you can see it's not that easy. But then with reconstruction, you can actually get good results. The other example, what we did is so with again same with ultrasound, but in this case, this is echocardiography. That means because especially for heart. So for a lot of heart diseases, ultrasound is very important, and echocardiography people do. But then echocardiography, you need to measure certain kind of structures, and with these measurements like ejection fractions is an important biomarker. What we call say biomarker, it's these measurements will help clinicians, your doctors, to assess, to decide whether you have certain kind of disease or not, whether you should be taking certain medicines or not. So that decision depends on certain kind of measurements. But if these images are not acquired properly, if there are poor quality images acquired, then it can be, you can get wrong results. So it's important to have right quality images. And here what we show is like, earlier showed with the uncertainty, we can do active learning to a certain point. Here we are using that uncertainty to let the operator know, okay, this is not a good, so quality control, this is not a good image, take another one, and then take the measurement. So it's uncertainty estimation for quality control. This is what we do, especially for estimating structures. The other example is something to enable people to do certain technology or certain kind of diagnosis, certain kind of intervention, clinical intervention in places where it was not previously possible. So one example is 2D to 3D reconstruction. So in countries like Nepal, you have certain kind of trauma surgeries, or where you have a fracture, you have certain kind of, you fall from somewhere, and then you need to do a surgery. Ideally, lots of doctors or orthopedic surgeons these days want to have CT scan, because with CT scan, you can see the whole 3D structure. For example, here you see a vertebra, so in the spine, and to see the whole 3D structure and exactly what has happened, CT scan is preferred, which will allow them to plan the surgery well. But in most of the small towns and villages in Nepal, you don't have CT scan because it's expensive. It takes, I don't know, but in the orders of crores. But X-ray is portable and easy and available everywhere. So when you have X-ray available, but not CT scan, The challenge with X-ray is you can get this kind of 2D views. So you can see here, one is taken from left to right here of a whole spine, here from front to left, and you can see the bones like spine and the pelvis, right, femur, this kind of things, but it's not in 3D. But what is happening currently in many places in remote areas is the surgeons do certain kind of surgery even with this kind of view, because if they don't do it, the patient will say, they don't, I mean, it's hard for them to go to headquarters or come to city to sit, to major towns to do CT scan, and then because it's expensive, it takes time. So they might just stay there, and so that's even more problematic. So despite suboptimal outcome of surgery, surgeons prefer to do certain kind of surgeries in those areas. So what we want to do now is, how about reconstructing 3D from these two views, which ideally goes closer to the cities, what we can see in CT scan. So that's what we're doing here. So you have like vertebra or pelvis with two orthogonal views, like what we usually get in X-ray. We want to reconstruct this kind of 3D detailed structure. So if we can do that, then it's much more less expensive, easy approach, which can be used anywhere to do the reconstruction and then do the surgery, which could potentially get better outcomes. So this is an ongoing research that we're doing. The other advantage of AI systems in countries like Nepal is, if you look into hospitals like Abir Hospital, teaching hospital, what's the major problem? Can anyone tell me? What's the problem? Why don't everyone go to government hospitals? And what is the problem? Yeah, exactly. So one of the major problems is too crowded. It takes ages to. So but then it's cheaper, and so a lot of people obviously would want to go there. And when many people go there and there are less number of doctors or radiologists, there are less number of health service providers, it's crowded. So we don't have the proper patient and doctors ratio. And in these scenarios, when there is less amount of time, very small amount of time with doctors, they speed up things, so there can be potentially mistakes. So it is, the quality could also degrade. So with AI, there is a big potential here also to speed up things and improve the quality in this kind of hospitals. And I'll give you one example that we worked some time ago, and also published this work, is estimating the curve angle. So when we say curve, so this is scoliosis. Scoliosis means the spine gets bent. You might have seen some people with that. So there's a certain kind of bent, curvature on the spine, and the surgeons or the doctors need to know the angle, exact angle, to decide what kind of treatment to do, whether to do therapy, whether to do surgery, or how it's progressing. So to monitor also, it's important. And to take the angle, the one needs to find the biggest bent, like which vertebra is most bent, tilted, and then draw tangent lines from those and then detect angles. So it's a tedious process. It's error prone and it takes time. But what we can do with deep learning models these days is you can identify all these landmarks and actually automatically estimate the angle. So which will definitely save a lot of time and also potentially make it consistent, right? So this is another example. So that's amazing. And we have many other researches, but obviously for the sake of time, I stop it over here for the imaging. But as I said, we have other kind of work we do, and this is natural language processing. So with language, we work especially in Nepali language and hopefully in the future in other local languages in Nepal. And what you see here is a real-time dashboard that we have for analyzing the social media posts on COVID-related tasks. But this is for Nepali language. So people post lots of things in Twitter, in other areas, and for public health professionals, it is important to know what kind of discussions is happening. Sometimes it can help even to detect early the epidemics, because usually when certain things like certain people dying or lots of people having disease suddenly happens, it comes out in the news or in social media before formally on the data systems, government systems. It takes time for the government or the major health systems to know about that. But social media and on the or general media might already publish about that. Or you might have heard on unknown kid, not hapaeko rogle yatina mare or yatina birami pare. So as soon as those happens, if a centralized system can detect those automatically, then it provides early warning system, right? So this and during especially during pandemics like COVID, it is also important to know what the public is thinking about the lockdown policies, about the symptoms, because we know that with all these variants, there were symptoms were changing all the time. So what kind of symptoms we see at the pattern at the population level? So this kind of analysis is really important, and this is what we were doing, what we call as social listening. This is now a formal term used internationally, social listening, where you can use AI systems to listen to the social media, right? So that's the health application. The other one we're working on is online abusive text detection. So the online violence, which can be in terms of abusive text, abusive or obscene videos, imageries, and even between intimate partners, because there's lots of interaction now online between partners, and there can be bullying or violent behaviors. So how to control these measures? It's extremely difficult because the internet is big and it's very hard to really do this sort of activity. But one of the important steps, if we want to do anything, is to be able to automatically detect the abusive texts, right? And this is what we do here in Nepali language. In real time, we can detect different abusive texts, what kind of abuse it is. And this is a deployed system on which we intend to build more robust systems and hopefully be useful for the applications. So that's a few examples of the language. We do work in epidemics also, but then, as I said, so that was some of the works our research group does. But at Naami, we have many other research groups, and for so genomics, so Raunak has the computational genomics lab, and there's multiple works being done there, like mostly focusing on infectious disease and cancer genomics. So one of the works we are doing is to so tuberculosis is yet another big problem in Nepal and other LMICs. We heard a lot about COVID, but tuberculosis kills many people every year. And especially these days, the challenge is the drug resistance of this bacteria. There were antibiotics, there were medicines for tuberculosis, but bacteria is now resisting. And the medicines or antibiotics that was already working in previous years are not working now. But we need to identify which bacteria it is in the patient if we want to properly manage it. And we are working on predicting that from the whole genome sequence, and also to understand different kind of mutations, how they interact with each other to develop easy tests for detecting early the resistance, what kind of drug it resists to, because there are 14 different antibiotics right now. And if a doctor wants to choose one of those 14, which one to choose? So it's important to know to what kind of drugs it is resistant to, right? So this is one example where we are working on the mutations, protein-protein interaction data, and predicting this. Raunak is also working on the genomic epidemiology of the SARS-CoV. And so this, I'm not the expert on this one, so I just put the slide here. That's him and his team doing. We have other teams like Sharif's working on endoscopy data, and the other team on especially working on neurological disorders with Naami from Yale and Naami with other teams. So here, this is also another interesting applications and can be extended to many other topics. Is what we do is with the video. So here we're just showing the this is a PDF, but actually these are videos where there are certain protocols with which the patient is asked to move their hands, head in a specific way. And for people with dystonia, in this case, dystonia is a neuromuscular disease, they are unable to do that in a normal way. So they have a very abnormal pose sometimes, or if we ask them to raise the hand, they might be able to just do up to this, or in a very abnormal different ways. And neurologists need to measure this abnormality in order to plan the treatment. But the problem is, because there is a complex movement happening, for them to score, they give scores, but it's very, even for the same patient, same video, multiple neurologists may give different scores, and which will lead to different treatment pathway, which is not what we want. We want consistent measure, right? And for this, we can track these points, individual points with deep learning and AI. And we are building a biomarker, more consistent biomarker. We're doing research on that to find more consistent, more objective way, right? So the other team, so Vinod just talked mostly, so I think you already know most of what he does, but working on both theoretical and applied research with the team on doing, I mean, with multimodal data that comes from vision, text, and speech, and some examples like here, it has shown already, is doing active learning on endoscopy, and then transformers for the surgical applications. So surgery, during the surgery, being able to understand or identify different objects, different states, organs can be very important for quality control, for assisting the surgeons, and potentially robotic surgeries. So there are lots of applications with this on which they are working on. And also the language, as I said, we don't work just with the images, but also with language. This is a large language corpus being trained. So if you, some of you work on NLP, I think it's worth looking into this paper. Then we also do like in collaborations or sometimes, I mean, they're doing this theoretical work. So I won't go into details. I think we don't have much time, but what kind of things this is doing is trying to improve certain aspects of deep learning by being able to, let's say, so in this case, it's trying to improve the general image quality of the GANs with specific kind of loss function, and with which is with some certain assumptions on how these input samples or the generated samples lie in the image manifold. So I don't know how much of training or AI background we have in terms of, but yeah, maybe I'll skip the technical details. But do you understand manifold, all this was? Okay, right, okay. But I mean, this is some example. Like the other examples is on the neural architecture search. That's again his team, the Suman doing. Is there are lots of neural network architectures, but then can we have learning tools, ways where you can actually search instead of manually designing these neural network architectures, let the machine learn on its own the best optimal neural architectures. So this kind of problems are very interesting, especially if you want to develop low cost, low computational resource or highly optimal architecture. So these are some of the works. Some other theoretical. So it's just to show that there are many theoretical works also we do. And then there are also teams like Azad, Danda, and others working on 3D reconstructions in robotics applications, augmented reality, doing large scale like simultaneous localization and mapping, or 3D reconstruction of indoor or outdoor environments. And there are very interesting, difficult problems in this where they are trying to tackle. Especially, for example, with Rashid. So what you see is there are different kinds of these features descriptors in image. So from images, you can take the features, and these feature descriptors, some are slow or fast, some are very fast, but very less accurate. Others are highly accurate, but very slow. And if you want, for example, robotic application, you want to have a robot that can move very fast, you want to be able, I mean, you should be able to compute these features very fast, and the slow methods won't work. And but then when you go to fast methods, it's not as accurate. So there is a trade-off, and what they are working on is trying to find the optimal kind of solutions, which is both reasonably accurate and reasonably fast. Right, so this is exams, and with the AI, there is also a theme where at Naami people work on AI and society. So it brings on ethical aspects, issues, societal challenges, or opportunities, because we need to understand what kind of things we can do, what are the potentials, how can we maximize the potential while minimizing the potential harms. Right, so this kind of things are, it's a nascent field, and it's not just Nepal, it's the whole world is actually just in a learning stage. Nobody knows exact solutions for many of these problems. So it's important to do research on this kind of topics. People doing that within Naami. This is another example where I myself is involved in a large global, like there are 100 scientists around the world that are working in healthcare and AI, where we're building this guideline on future AI framework. So this is about all these different kinds of ethical questions, trustworthiness, explainability, interpretability. Those kind of things are distilled down into these major 6 principles with fairness, universality, traceability, usability, robust explainability. So when I'm just showing this as an example, and these are the researchers from these many countries involved for this building this guideline. We are just submitting this paper shortly. And I'm involved here from Nepal. Yeah, that's pretty much, I think, a brief overview of what we do at Naami, and I hope with so many teams we have at Naami, some of you would be interested to join us. Do reach out to us, and happy to take questions. Thank you.
But yeah, here's the question. So I'd like to ask you again, Vijay sir. Thank you for a wonderful and wonderful presentation with some applications, and that happens in real life. My just query is just basically, what is the accuracy of your AI-based system for any your smartphone for managing cancer screening or any other diseases? What is the accuracy?
Yeah, so it all depends on individual specific application and specific task one is doing. And so a lot of these, what I showed, especially for the smartphone ones, are the system in progress. So they are we're still collecting data and working. But in fetal ultrasound, for example, we have publications where we show accuracies. I mean, we have to see not just accuracy, both the sensitivity and specificity, or what we call as precision and recall, because you need to be, you should reduce both false positive, false positive, and the maximize the true positive, right? So there's two aspects, and it all depends on what is the best. Like we cannot say, okay, 90% is good for everything. It all depends on each particular application and how much of benefit it does to the existing system, and whether the end user. So end user could be a doctor, it could be a like us, like if we are doing a face recognition system for Facebook, right? And someone is using Facebook and there's a tag, it suggests tag. So the accuracy for that perhaps is required accuracy is less than that for the cancer screening. So it depends all on the, and also the prevalence. And the other part is especially for cervical cancer. Let's say it says it's suspicious. Then the person has to go to the center, another center, to do advanced test. And the other outcome is the person, the system says you do not have any precancers. Then the person goes back. So in these two cases, which one is more dangerous?